Today we shall discuss maximization in assignment problems by using Hungarian method. Approach. First, check for balance, that is the number of rows is equal to number of columns. If not balanced, then it should be balanced by adding a row or column with dummy entries before applying the algorithm. Step 1. Convert the given problem into minimization problem by subtracting all the elements from the largest element. Step 2. Follow the same method that was used to solve minimization problem as follow. Row reduction matrix. Subtract the smallest cost element of each row from all the elements in the row of the given cost matrix. See that each row contains at least one zero. Column reduction matrix. Subtract the smallest cost element of each column from all the elements in the column of the resulting cost matrix obtained by step 1 and make sure each column contains at least one zero. Step 3. Assigning the zeros. Draw minimum number of horizontal and vertical lines, n, to cover all zeros. Examine each row. If number of 0 in the row is 1, then mark it and delete the corresponding column by drawing a vertical line, and if number of 0 in the row is maximum, that is more than 1, then skip. If all the zeros are not covered by the lines, then column examination is done. Examine each column. If number of 0 in the column is 1, then mark it and delete the corresponding row by drawing a horizontal line, and if number of 0 in the column is maximum, that is more than 1, then skip. Step 4. Apply optimal test. If each row and each column contain exactly one marked 0, then the current assignment is optimal. Minimum number of horizontal and vertical lines drawn, n, to cover all the zeros. A. If n is equal to n, where n is the order of the matrix, then an optimal solution can be made. B. If n less than n, then go to next step. Step 5. Modify the matrix. Determine the smallest uncovered elements x. Write uncovered value is equal to uncovered value minus x. Intersection value is equal to intersection value plus x. Line value, that is other value, are same. Step 6. Repeat steps 1 to 5 until an optimum assignment is obtained. Let's understand with an example. Example. Solve the following assignment problem using Hungarian method for maximization of output. Solution. In this matrix, these are jobs and these are machines. First, check for balance, that is whether the number of rows is equal to number of columns. Here 4 jobs and 4 machines. Problem is balanced. Matrix is of order n is equal to 4. Switch P1. Convert the given problem into minimization problem by subtracting all the elements from the largest element. The largest number is 115. 115 minus 60 is 55. 115 minus 90 is 25. Similarly, we subtract all the other element from 115. We get this matrix. Step 2a. Subtract the smallest cost element of each row from all the elements in the row of the given cost matrix. See that each row contains at least one zero. Here, smallest element in row 1 is 10. Subtracting 10 from each element of row 1, we get 45, 15, 0 and 25. Smallest element in row 2 is 5. Subtracting 5 from each element of row 2, we get 30, 20, 0 and 25. Smallest element in row 3 is 5. Subtracting 5 from each element of row 3, we get 45, 15, 0 and 20. Smallest element in row 4 is 0. Subtracting 0 from each element of row 4, we get the same element. The matrix obtained is this. Step 2b. Subtract the smallest element of each column from all the elements in the column of the given matrix. Smallest element in first column is 30. Subtracting 30 from each element of column 1, we get 15, 0, 15 and 10. The smallest element in second column is 15, so subtracting 15 from each element of column 2, we get 0, 5, 0 and 15. Smallest element in column 3 is 0. Subtracting 0 from each element of column 3, we get the same element. Smallest element in fourth column is 20. Subtracting 20 from each element of column 4, we get 5, 5, 0 and 20. The matrix obtained is this. Step 3. Assigning 0. Examine each row. In this first row, there are more than one 0, so skip the row. In the second row we see 2 zeros, so skip this row. In the third row we see more than 1 zeros, so skip this row. In fourth row only 1 0, so we mark it and delete that column by drawing a vertical line. Now we see zeros uncovered by lines, so we start column scanning. First column, only 1 0, so we mark it and delete that row by drawing a horizontal line. Second column, 2 zeros, skip. Third column is deleted. Fourth column, here we see only 1 0. So mark it and delete the corresponding row by drawing a horizontal line. We go to second column. Now, there is only 1 0, as other one got covered by line, so mark it and delete the row. Now check whether all the zeros are covered by lines. Here, n is equal to 4. N is equal to 4. N is equal to n. So optimal solution is possible. Where the optimal assignment, machine and job is as. First job, machine to production 90. Second job, machine 1 production 80. Third job, machine 4 production 90. Fourth job, machine 3 production 115. The total production is equal to 90 plus 80 plus 90 plus 115 is equal to 375.